All right, let's dive into something pretty cool today. Something called Python Robotics.
Okay.
Have you heard of this?
I have heard of Python Robotics, yeah.
Yeah, so this is it's an open source project,
Right.
and it's kind of blown up on GitHub,
Yeah.
and for good reason.
Yeah.
So it's not just like code, but
Yeah.
it also has this textbook built in that explains all these robotics algorithms.
Yeah, it's a fantastic way to learn and kind of get your hands dirty at the same time.
Right. Yeah, it's a really cool combination. That's probably why it's one of the top robotics projects out there.
Yeah, definitely.
So I'm curious, like for somebody just starting out in robotics,
Yeah.
what would be some of the biggest hurdles that they might face trying to, use this?
I think even though it's meant to be user-friendly, there's always a learning curve with something this complex. So
Sure.
even if you're a pretty experienced programmer,
Hmm.
you might trip up on like setting up the environment
Right.
or understanding all the dependencies.
Hmm.
And then, of course, there's always the underlying, you need a decent grasp of linear algebra and calculus to really get what's going on under the hood.
Yeah. Yes. The math hurdle.
Yeah. Yeah.
Can't really escape that.
No, it's always there.
But I guess that's where the textbook part comes in handy.
That's right.
So I was looking at the table of contents, and honestly, just looking at that, I was a little overwhelmed. There's just so much there.
Yeah.
We've got things like SLAM, path planning strategies, arm navigation, even stuff on bipedal robots and aerial navigation.
Yeah, it's an incredibly comprehensive resource.
Yeah.
It covers a lot of ground, which can be intimidating at first.
Yeah. It's like, where do we even begin?
Right, exactly.
Maybe we can start with a concept that's pretty foundational to, I would say, almost all robotics,
Sure.
and that's the SLAM.
Yeah,
So SLAM stands for Simultaneous Localization and Mapping.
that's right.
And so imagine like you have a robot. It's exploring a completely unknown environment. It has to build a map of its surroundings.
Right.
But it's also trying to figure out its own location on that map.
At the same time.
At the same time, yeah.
Yeah.
So it's like if I was walking through a city for the first time
Right.
and I was trying to draw a map, but I had no GPS.
Exactly.
No sense of direction.
It's a computationally intensive problem.
That sounds ridiculously difficult.
It is, yeah.
Oh my God.
Think about how we as humans do it.
Mm-hmm.
We use our senses to gather information about our surroundings,
Right,
and then our brains kind of create this mental map.
right.
So robots need to do the same thing,
Yeah.
but they have to rely on sensors and complex algorithms to achieve that.
So basically, this SLAM is like the robot's way of making sense of the world around it.
Exactly, yeah.
Okay, that makes sense. Now, another thing that caught my eye was this rapidly exploring random trees method,
Okay.
and that's for path planning.
Yes.
So how does that work, and what makes it stand out compared to other ways of getting a robot from point A to point B?
Yeah, so what's really cool about RRT, as it's often called,
Okay.
is that it's incredibly flexible.
Okay.
So imagine a robot that's trying to navigate a really cluttered warehouse,
Mm-hmm.
but the layout of the warehouse changes every day.
Right.
RRT can handle that kind of dynamic environment
Mm-hmm.
because it doesn't rely on a predefined map.
So it doesn't have to like know the map ahead of time.
Exactly.
Oh wow.
It's constantly exploring and adapting its path based on what it encounters.
So it's not just about finding the shortest path.
Right.
It's about finding a path that works
Exactly.
in a changing environment.
Yeah.
That's pretty crucial.
Yeah, especially if you think about real-world applications like search and rescue,
Right.
or even something like autonomous delivery robots.
Right. Those are great examples.
Yeah.
Okay, that makes a lot of sense.
Yeah.
So it's adaptable. That's what makes it so powerful.
Exactly.
And it's not just theoretical. It has like real world implications.
Yeah, absolutely.
That's great. That's a great segue to the next thing that jumped out at me, which is arm navigation.
Okay.
So we're talking about robots with arms now
Yeah.
that can like move around objects, right?
Yeah.
I'm guessing it's not as easy as just telling the arm to, go there.
No, not at all. Programming robotic arm movement involves a whole field called inverse kinematics.
Okay.
So imagine like you're reaching for a cup of coffee. Your brain instinctively figures out how much to bend your elbow, your wrist, to grab that cup.
Right.
Now imagine doing that for a robot arm
Yeah.
with multiple joints.
Oh, wow. So it's like multidimensional geometry,
Exactly.
but in real time.
You got it.
That's pretty crazy.
And it's not just about reaching the target, it's about making sure the arm doesn't collide with anything along the way.
Oh, right. Of course.
So that's where collision detection comes in.
Right. We don't want any robot arms knocking stuff over. So Thinking about all these different types of movement, the bipedal and the aerial navigation sections really make me think about just how diverse the world of robotics is.
Hmm.
Like, we're talking robots that walk on two legs,
Yeah.
and drones that can navigate complex airspace.
And Python Robotics gives you a taste of both of those things.
That's really cool.
Bipedal locomotion, for instance, is incredibly complex.
Yeah.
It's about mimicking the balance and coordination of human walking.
Which we kind of, as humans, take for granted.
We really do.
Like, we don't even think about it.
It's only when you try and program a robot to do it that you realize how much is going on.
Yeah.
And then you have aerial navigation,
Mm-hmm.
which is a whole other set of challenges, dealing with wind gusts and maintaining stability in flight.
So we've got robots learning to walk and drones that can navigate tight spaces, all using Python Robotics as a starting point.
Exactly.
I'm curious, though, what are some of the practical applications of this project? Like, if I wanted to build a robot using what I've learned from Python Robotics, what kind of real-world problems could I tackle?
Well, the beauty of Python Robotics is that it lays a foundation you can build upon for all sorts of applications.
Okay.
So take the path tracking section, for example.
Mm-hmm.
Imagine you've got a robot that needs to deliver packages in a warehouse.
Right.
Planning the route is one thing,
Mm-hmm.
but ensuring that the robot stays on track is another.
Especially in a busy environment
Exactly.
where things are moving around.
Yeah, with obstacles popping up all the time.
Yeah.
So that's where algorithms like Pure Pursuit come in.
Okay.
It's like a self-correcting navigation system for your robot.
Oh, interesting.
It constantly adjusts the robot's movements to stay on that desired path, even with slight deviations or disturbances.
So it's kind of like a car's lane keeping assist, but for a robot?
A very apt analogy.
Okay.
And just like with driving, the complexity ramps up when we move beyond those simple scenarios. So the sections on arm navigation, aerial navigation, and bipedal, those dive into controlling robots with many more moving parts.
Yeah, I was looking at those sections earlier, and it's pretty mind-boggling.
Yeah.
Like, to think about coordinating the movements of, like, a robotic arm or stabilizing a drone, like, mid-flight,
Yeah.
must require some serious computational power.
Absolutely.
Wow.
And that's where the control section of Python Robotics comes in handy.
Okay.
It introduces concepts like feedback control,
Mm-hmm.
which is all about using sensor data
Okay.
to constantly monitor and adjust the robot's behavior.
Right.
And it's what allows a robot to react to its environment in real time.
Could you give me an example of how that works in practice?
Sure, imagine you have a robot arm
Mm-hmm.
that's designed to pick up really delicate objects.
Okay.
The arm needs to be strong enough to lift the object, but also sensitive enough to not crush it.
Right.
So feedback control would allow the arm to sense the pressure that it's applying
Mm.
and adjust its grip accordingly.
So it's almost like the robot is developing a sense of touch.
You got it.
That's pretty
It
cool.
reminds me of like those surgical robots that they use in hospitals.
Oh, right.
The precision that they require must rely heavily on feedback control.
Absolutely.
And to really understand how these systems work,
Yeah.
you need to be able to analyze the data they generate.
Right.
That's where the utility section comes in.
Right, because there's like tools in there for plotting and visualizing data, so you can
Ah.
kind of see what the robot's actually doing.
Yeah, it's like having a window into the robot's brain,
Yeah.
so to speak.
Yeah.
It allows you to debug,
Right.
fine-tune, really get a feel for how your code is translating into real-world actions.
So with all this talk about algorithms and control systems, it makes me wonder, like, who is Python Robotics really for?
That's a great question.
Is it only accessible to, like, very experienced programmers?
Right.
Or can someone with, like, basic Python knowledge dive in
Yeah.
and start learning?
I think the answer is both. The project definitely benefits folks with a stronger coding background.
Right.
But the way it's structured, even someone who's relatively new to Python can get a lot out of it.
Okay.
The examples are well commented,
Yeah.
and the textbook explanations are pretty clear.
So it's kind of like you can choose your own adventure.
Exactly.
You can go as deep as you want,
Yeah.
as your current knowledge allows.
You can start at a surface level,
Yeah.
and then as you learn more, you can dig deeper.
And there's always more to explore.
Exactly.
Yeah. That's really cool.
And that's what makes it such an exciting resource.
Mm-hmm.
It caters to a wide range of skill levels.
Right.
So it's encouraging everyone to explore the world of robotics.
Yeah, it kind of demystifies robotics a bit.
It
Like, it's not this exclusive club.
Yeah.
It's something that anyone can get involved with.
That's the spirit of open source projects.
Yeah.
They democratize knowledge
Yeah.
and empower anyone with curiosity to become a creator.
I love that.
And speaking of creating, you were asking earlier about real-world applications.
Right. Like, what are some of the ways Python Robotics is being used out there in the wild?
Yeah, the possibilities are pretty vast.
Okay.
We're seeing applications in everything from manufacturing and logistics to healthcare and agriculture.
Wow.
Autonomous vehicles are a big one, of course.
Yeah.
But there are also robots being developed for tasks like search and rescue, environmental monitoring, and even space exploration.
It feels like we're at the beginning of a robotic revolution.
In many ways, we are.
Yeah.
And what's exciting is that Python Robotics is playing a role in driving that revolution forward by providing an accessible platform for people to learn, experiment, and build the next generation of robots.
It's amazing to think about the potential impact.
It is.
But as with any powerful technology, I imagine there are bound to be some ethical considerations as well.
Absolutely. As robots become more integrated into our lives, we need to think carefully about the implications for things like job displacement, privacy, how data is collected and used, and even potential biases in algorithms.
So we don't want to blindly create technology without thinking about the consequences.
Exactly.
Yeah.
And that's where I think the open source nature of Python Robotics helps. Transparency and collaboration can make the development process more ethical. When the tools and knowledge are open, it's easier to have these important discussions.
So it's not just about writing the code.
Right.
It's about building a responsible robotics community.
Exactly. It's about asking questions, challenging assumptions, and working together to ensure these technologies benefit everyone.
That's a great point.
So we've talked a lot about the software side of things.
Yeah.
But I'm curious about the hardware.
Okay.
We know Python Robotics doesn't dictate specific hardware.
Right.
But how does it help bridge the gap between the code and building actual physical robots?
Yeah, like how do we go from these lines of code to a robot actually moving around in the real world?
That's where the choice of Python itself becomes really significant.
Okay.
You see, Python is hugely popular in the maker and DIY electronics communities, especially with platforms like Raspberry Pi and Arduino. These are like tiny, affordable computers you can program.
Right.
And they often form the brains of homemade robots.
So the coding skills you build up with Python Robotics translate well to controlling motors, reading data from sensors, all that hands-on stuff.
Absolutely. And what's great is you can start small.
Okay.
There's no need for a fancy lab or tons of cash.
Right.
You could start with a simple robot that moves on wheels.
Okay.
Add some distance sensors so it avoids bumping into things and build up from there.
That's reassuring because I think a lot of people assume that robotics requires this, like big initial investment.
Huge upfront costs.
Right.
Yeah, but the barrier to entry is lower than ever. Plus, the communities around projects like Python Robotics are super welcoming to beginners.
That's good.
There are tons of tutorials, forums, people sharing their projects openly.
Right.
It's a great environment to learn in.
So we keep coming back to this accessibility theme.
We do.
With Python Robotics, like it's designed to be more than just a software library.
I think that's spot on.
Yeah.
It's about making robotics engaging for anyone who's curious, not just academics or industry pros.
So it's like for the people robotics.
Exactly. And that ties into the potential for real-world impact.
Right.
We were talking about applications earlier.
Yeah.
If our listener wanted to take their Python Robotics knowledge and actually build something, where would you point them?
Yeah, besides all the info that's in the project itself, what other resources would you recommend?
Well, for those starting with the hardware side, the official Raspberry Pi and Arduino documentation is excellent. They've got step-by-step guides on basic electronics and programming, which is essential when you're dealing with physical components.
And what about for those who are ready to take on more challenging projects?
Online communities are a gold mine.
Okay.
Websites like Hackaday and Instructables, they have thousands of DIY robotics projects, from simple line-following robots to incredibly complex things like robotic arms and even autonomous drones.
Wait, people are building autonomous drones in their garages using these resources.
It's amazing, right?
It's wild.
Yeah, it speaks to the power of open source hardware and software.
Right.
The tools and knowledge are out there. It's all about what you decide to build.
It's almost like Python Robotics isn't just about robotics.
Yeah.
It's like a gateway to this whole maker culture.
It is.
This idea that anyone can build and invent.
That's a really interesting point.
Yeah.
It's not just about the specific algorithms.
Right.
It's about empowering people to become creators and problem solvers.
I'm definitely feeling inspired to dig out my old electronics kit.
You
But before we unleash a wave of new robot builders on the world,
Yeah.
maybe we should talk about the ethical side of things again.
Absolutely.
Because building cool robots is fun,
Yeah,
but it's crucial to consider the impact they'll have.
it is.
We talked about things like job displacement
Yeah.
earlier, and there are also concerns about privacy,
Right.
how data is collected and used,
Yeah.
and even potential biases in algorithms.
It's a lot to think about.
It is. We don't want to just blindly create technology without thinking about the consequences.
No. And that's where, again, I think the open source nature of Python Robotics helps.
Okay.
Transparency and collaboration can make the development process more ethical.
Okay.
When the tools and knowledge are open, it's easier for everyone to see what's going on
Right.
and to have these important discussions.
So it's not just about writing the code.
Right.
It's about building a responsible robotics community.
Exactly. It's about asking questions, challenging assumptions,
Mm-hmm.
and working together to ensure that these technologies benefit everyone.
That's a great note to end on.
I think so, too.
We've explored a lot in this deep dive.
We have.
From like the technical details of algorithms
Wow.
to the broader implications of robotics in society.
It's a big topic.
It is a big topic.
But hopefully we've sparked some curiosity
Yeah.
and inspired our listener to explore Python robotics further.
I think we have. So now if you'll, excuse me, I've got some robots to build.
All right, go build some robots.
Thanks for joining us on this deep dive, everyone.
See you next time.
Yeah, so it's like, it's not just about finding the shortest path. It's about finding a path that works in a changing environment,
Yeah, that's pretty crucial.
especially when you think about real-world applications, like search and rescue,
Right,
or even like autonomous delivery robots.
right. Those are great examples.
Yeah, so that adaptability is what makes RRT so powerful.
It's not just theoretical. Like, it has real-world implications for how we design robots to operate in those unpredictable environments.
Okay, so that kind of leads into the next thing that jumped out at me, which is arm navigation. Oh, so
Okay.
we're talking about robots with arms now
Yeah.
that can like move around objects, right?
Right.
I'm guessing it's not as easy as just telling the arm like go there.
Not at all. No programming robotic arm movement involves this whole field called inverse kinematics.
Okay.
So imagine like you're reaching for a cup of coffee.
Mm-hmm.
Your brain just instinctively figures out how much to bend your elbow, your wrist
Yeah.
to grab that cup.
Right.
Imagine trying to do that for a robot arm
Yeah.
with multiple joints.
Oh, wow.
It's like solving a multi-dimensional geometry puzzle, but in real time.
Yeah, that's pretty crazy.
And it's not just about reaching the target.
Right.
It's also about making sure that the arm doesn't collide with anything along the way.
Oh, of course. Yeah.
So that's where collision detection comes in.
Right. We don't want any robot arms knocking stuff over.
Exactly.
So thinking about these different types of movement, the bipedal and the aerial navigation sections really make me think about how diverse the world of robotics is.
Mhm.
We're talking about robots that walk on two legs and drones that can navigate like complex airspace.
Yeah, and Python Robotics gives you a taste of both.
That's really cool.
Bipedal locomotion, for instance, is incredibly complex.
Yeah.
It's about mimicking the balance and coordination of human walking.
Which, when you think about it, we kind of take for granted as humans.
We really do.
Yeah.
It's only when you try to program a robot to do it that you realize how many subtle adjustments and calculations our brains are constantly doing.
Yeah, that's a good point.
And then you have aerial navigation, which is a whole other set of challenges, dealing with wind gusts and maintaining stability in flight.
So we've got robots learning to walk and drones that can navigate tight spaces, all using this like Python Robotics as a starting point. I'm curious, though, what are some of the practical applications of this project? Like if I wanted to build a robot using what I've learned from Python Robotics,
Yeah.
what kind of real-world problems could I tackle?
Yeah, so it's really about bridging that gap between the software and the hardware.
Okay, so how does Python Robotics help someone go from like lines of code to an actual robot moving around in the real world?
Well, that's where the choice of Python itself becomes really significant.
Okay.
You see, Python's hugely popular in the maker and DIY electronics communities.
Right.
Especially with these platforms like Raspberry Pi and Arduino.
Okay, yeah, I've heard of those.
So these are like tiny,
Yeah.
affordable computers that you can program.
Right.
And they often form like the brains of a lot of these homemade robots.
So the coding skills that you build up with Python Robotics
Yeah.
translate well to like controlling motors, reading data from sensors, like all that hands-on stuff?
Absolutely. And what's great is you can start small.
Okay.
There's no need for a fancy lab or tons of cash up front.
That's good, because I think people assume that robotics always requires this, like,
Yeah.
huge initial investment.
Yeah, it can be intimidating.
Yeah.
But the barrier to entry is lower than ever these days, really.
Okay, that's good.
Plus, the communities around these projects, like PythonRobotics, are super welcoming to beginners.
Right.
There are tons of tutorials, forums, people sharing their projects openly. It's a great environment to learn in.
Yeah, it seems like we keep coming back to this theme of accessibility with Python robotics.
Who do?
It's like it was intentionally designed to be more than just like a software library.
I think that's spot on.
Yeah.
It's about making robotics engaging for anyone who's curious, not just academics or industry professionals.
Right.
And, speaking of engaging and being curious, you were asking earlier about real-world applications.
Yeah.
Like, if our listener wanted to take their Python robotics knowledge and actually build something, where would we point them?
Yeah. Besides all the info within the project itself, are there other resources that you'd recommend?
Well, for those starting with the hardware side, the official Raspberry Pi and Arduino documentation is excellent.
Okay.
They've got step-by-step guides on basic electronics and programming, which is essential when you're dealing with physical components.
And what about for those who are ready to take on more challenging projects?
Yeah, online communities are a goldmine.
Oh, really?
Websites like Hackaday and Instructables have thousands of DIY robotics projects.
Wow.
From simple line-following robots to incredibly complex things like robotic arms and even autonomous drones.
Wait, people are building autonomous drones in their garages using these resources.
It's amazing, right? It speaks to the power of open source hardware and software.
Yeah.
The tools and the knowledge are out there. It's all about what you decide to build.
So it's almost like Python robotics isn't just about robotics. It's like a gateway to this whole maker culture, this idea that anyone can build and invent.
That's a really interesting point.
Yeah.
It's not just about the specific algorithms. It's about empowering people to become creators and problem solvers.
Okay, I'm definitely feeling inspired to dig out my old electronics kit.
Do it.
But before we unleash a wave of new robot builders on the world, maybe we should talk about the ethical side of things again.
Absolutely, it's important.
Building cool robots is fun,
Yeah,
but it's crucial to consider the impact they'll have.
it is.
We talked about things like job displacement earlier.
Right.
And there are also concerns about privacy, how data is collected and used, and even potential biases in algorithms.
All important things to consider.
Yeah, we don't want to blindly create technology without thinking about the consequences.
Definitely not.
And that's where I think, again, the open source nature of Python robotics helps.
Absolutely.
This transparency and collaboration.
Yeah, it can make the development process more ethical.
Okay.
When the tools and the knowledge are open, it's easier to have those important discussions.
So it's not just about writing the code, it's about building a responsible robotics community.
Exactly. It's about asking those tough questions, challenging assumptions, and working together to ensure these technologies benefit everyone.
That is such a great point to end on.
I think so too.
We've explored a lot in this deep dive.
We have.
From, the technical details of algorithms to the broader implications of robotics and society.
It's a big topic.
It is a big topic, and hopefully we've given our listeners some things to think about.
I hope so.
And maybe even inspired them to start building their own robots.
So go build some robots, everybody.
All right, thanks for joining us for this deep dive, everyone.
See you next time.